principle is actually really simple. It describes a situation in fluids. It's for non-compressible fluids, but air moving less than max speed does the same thing. But Bernoulli's principle states that if a fluid is moving, that is, it increases in speed, there's a decrease in static pressure. That's it. Bernoulli actually didn't work out the mathematics, somebody else did it for him. That principle you see in operation in things like aircraft. An aircraft wing, it's got a blunt nose and it has one curved edge that is longer than the other edge, and what that means is the air has to move quicker over the longer edge, and that creates a pressure differential. It creates a drop in pressure because the air under the wing has a higher pressure and it tries to get to the low pressure area, but the wing is in the way, so it acts across the whole surface of the wing, and that's where we get lift from. And because we get lift, we get aircraft flight. Another example of this is actually in a carburetor. If you take a cross-section of a carburetor and look at that tube, you'll see it's like two aircraft wings. It's a Venturi tube, and of course the same thing happens. We get an increase in speed and we get a drop in pressure. That drop in pressure can be used to suck the fluid up, which in this case is petrol, atomize it, spray it into your engine. So Venturi tubes use Bernoulli's principle, or rather they operate on Bernoulli's principle, and they're tremendously useful for lots and lots of things. Unfortunately, they're actually a little bit difficult and expensive to make, and that's a shame because they have another really good use, and that is in shrouding wind turbines. If you put a Venturi or a shroud around a wind turbine, of course you get exactly the same effect. In fact, you get two effects. One, you've increased the surface area that the wind can actually hit. Two, you get an increase in speed. And three, you get a reduction in pressure. So shrouds have been put onto wind turbines to increase their efficiency up to and beyond the Betz limit. I mean, it's really a bit of a cheat because you're using a bigger area, obviously. But they're great for things like wind turbines if you're going to run a single wind turbine for getting more out of it. Only problem is they're big, they're lumpy, they take a lot of material, and they're expensive to make, which is why an awful lot of wind shroud turbines have in fact failed to make it to market. So it would be great if we could find a cheaper solution. Now Venturi tubes are used a lot in industry actually for fluid flow. They measure fluid flow with them, and of course industry is driven very often by cost, and they came up with a thing called the orifice plate. The orifice plate is astonishingly simple. It's a flat plate with a hole in it, and it turns out that a flat plate with a hole in it behaves in the exact same way as a Venturi tube. It's only one tiny thing, it loses a bit of energy, but you always give something up. So if you give up a little bit of energy efficiency because you're getting a huge reduction in cost, then the cost of your energy produced actually goes up. And that's the thing I'm interested in. Remember this? This is our wind wall. It's a plank of wood with some holes drilled in it, and it's not there just to hold the fans in place. Actually, it is in fact an orifice plate. So what I've done is I've made easily a whole bunch of Venturis without having to muck around with egg cartons and plastic cups, and you do it all in one by drilling the holes out. Now, as I said, there is a small loss of efficiency, but I can pay for that because I haven't had to make 100 plastic cups to fit. What happens is the same thing that happens in a Venturi. So the wind hits here. We create a speed and low pressure which draws the wind in from about halfway between. I know it's about halfway between because I experimented to find what this distance was to get the most power out for the spacing of the different fans that I put on there. And this functions as a Venturi because it is an orifice plate. Now of course they're fans, so behind them they have this extra little bit like that. So we have created cheaply and easily a whole load of ducted wind turbines just by taking a thick piece of wood and drilling some holes in it. So by paying attention to the Bernoulli principle, watching what industry did, we've been able to create a very cheap way of connecting together a whole load of shrouded turbines, which is why, or rather one of the reasons it contributes to the higher efficiency of that particular wind wall. Anyway, I thought I would share that with you because a lot of people have been suggesting shrouds, but actually the shrouds are already there. I mean, it is 100% without a doubt we could improve the efficiency by making proper Venturi shapes, but you have to bear in mind how much that effort that would be and how much cost is involved there, because it's likely that the levelized cost of energy generated is in fact going to go up. Anyway, I thought I would share that with you. I hope you enjoyed the video and thank you very much for watching.